So I'm going to tell you basically how this template works and do demonstrations along the way to show you all the features of Steam VR motion control. So grab that template, you'll see there's a couple folders in it, drop it in your Super Elite folder. It's going to create an intermediate and a saved folder, and I just have a shortcut to Unreal Engine there for convenience. Open that up in Unreal Engine and this is what it looks like. Let's start with the player spawn zone. This is where the player is going to spawn. Now to figure out who exactly is going to be spawned, we're going to need a game mode. That game mode right here, I've called it Vive game mode, has chosen to spawn the Vive pawn as the default pawn class with the Vive controller as the default controller class. That's great. And to make sure your level is actually running that game mode, go to World Settings, Game Mode Override, and set that up. You can set a project-wide default, but I've just done that for here. So you'll notice this is clipping through the floor, and if you could read that, it would say bad size. That's because it's clipping through the floor. That's a problem if you're spawning a regular character, but the Vive is going to spawn with its origin at the headset, which starts 0, 0, 0 in the center of your floor. So as soon as you stand up, you'll become your appropriate height. If this were out of the floor, you'd stand up and your head would be far higher than you would be and your feet would be off the floor. So that's pretty much the only workaround that we have to do to make this work. So let's check out the Vive pawn that gets spawned. So there's the Vive pawn right there. I'm going to load that up. It's got a couple blueprints on here that are super common, and you're free to use and copy all this stuff as much as you want. Just don't sell this to people without changing it, because that would be stupid, because they can download it for free. Actually, I mean, if you do, that might be kind of clever. Tell me about it. Anyways, here's the Steam VR Chaperone component. Right here, you can drag this into your scene and you can do stuff with that. So you can create events to when you leave the bounds or return to the bounds. There's more stuff you can do under the Steam VR menu if you just type that in, or turn off context sensitivity. There's a lot of cool stuff in there. Anyways, I'm getting the bounds. Like, it's an array of objects that show up on the corners of your floor. For each of those objects, I'm spawning a particle emitter, and I'm spawning it attached, and I'm offsetting it by the location of those four corners. So let's see what that looks like. As you can see, there is a particle emitter over there. There's one over there, and the other two are covered up by objects. Generally what that does is let you see where you are in the game without having to walk into your chaperone, so you don't actually lunge through something. Keep in mind that you might need to make those more visible for players who aren't super familiar with VR, but in general they're great for even the most advanced players, because that way you never have to wonder how far you have to walk till you get to your chaperones or walk into a wall or something. So please put stuff like that in your projects to make it easy and fun and safe. The next thing we have here is a trigger axis. This is going to be the motion controller right trigger axis. To make your own one of those, you can type in motion controller trigger. Left for left, right. Now there's two things, trigger and trigger axis. Trigger is just going to be on or off. Trigger axis is going to give you an axis value. And for this, we want the axis value. Now there's also right or left. The way to do that is select your motion controller component, which you can add by typing in motion controller, and then select right or left from the drop down. So the left hand is left, the right hand is right. This orange, or actually yellow arrow, can be clicked to reset this value to its default, and that will actually be a good way to see that I've changed things around the scene as you look around. So what I'm doing here is pulling the value. Starts out at 0 when you're not pulling it, goes to 1 when you're pulling it, so that's going to lerp this value of being 0 to 45 as you pull the trigger. It's going to use the pitch of this rotator, and it's going to rotate this cone by setting its relative rotation. So here's the cone. It's out here. I don't know why that's what I've done, but that's what I've done. You're going to have to deal with it. I will have to deal with it. But let's see what that does. So right here we have this fantastic cone, and I pull the trigger and it tilts out like this. So I can do important things. I can play soccer or broom ball. Also, it's pretty sharp, so you need to be careful with that. Now you can see the other bit of the chaperone. Now we've got actually 3 visible, and there's the 4th one. If you are paying attention very well, you'll notice that I'm actually outside of the chaperone because I'm sitting on my chair. The next facet we're going to look at is the cool debug messages from important buttons. The left shoulder button, which is also the menu button, is a great button because when you click it, it's going to say left menu button. Likewise, there's 1, 2, 3 buttons, actually 4 buttons, kind of like a D-pad on the touchpad, just in here by default. So you can type in face button. Contact sensitivity usually helps. So you can see there's a lot of face buttons. There's more face buttons than these controllers have. That will make it very extensible for controllers that implement more buttons, obviously. With the left and right controllers here, it looks like you could have about 16 buttons, which would be fantastic. And make sure when you're putting something in to pay attention to the left or right controller. Switching those is easy and painful. So I'm going to jump in, and what this is going to do is print some strings to the debug log and potentially onto the screen here. So let's see if I have my left controller. This is my right controller, so nothing is happening. This is my left controller, so I'm just going to spam that button. And you could actually see that showing up on the screen just for a brief second. It says left menu button, and then I'm going to try to hit button 1 on a touchpad. And we want to see where those are. They're going to be in the output log. To get to the output log, go to your main scene. Like here the windows change a little bit, but you click on Window, Developer Tools, Output Log, and you can see there's all these clicks, which were typed in here by the print command. So the next cool feature is the thumbstick. I'm not going to demonstrate this because you can't feel the force feedback in the video. What I'm doing is I'm taking the axis value of the x-axis on the thumbstick. You get x and y values for each thumbstick. I'm grabbing the absolute value, so it always stays from 0 to 1, and I'm putting that as the intensity. So if you touch the touchpad with your thumb, it'll be somewhere along the x-axis, and if you move it towards the perimeters, it will increase the intensity of this force feedback. If you move it back, it'll decrease it. Now force feedback plays to a client, so you have to let it know which player is getting the force feedback. Also here I have checked the right large actuator. That's the one for the right hand. I'm not sure if the small ones are working right now. They weren't last time I tried. The next thing we have is the grips. I'm just running another force feedback from the left and right grip. You can click those and enjoy the fantastic feedback you get. There's also ways to make more advanced feedback. I haven't put them in here, but feedback, and I'm going to uncheck context sensitive, client play force feedback. Now here you could actually select an asset for the force feedback, which would be a fancy curve or something. I haven't done that. Usually I use this because I can dynamically adjust the intensity, much like I was doing up here through game events. The final thing we have here is the teleportation, and this is a little bit more complicated, but basically I get the position of the left controller, add the forward vector of the left controller, and that's going to be the start of the line trace. I've got a little bit of debug on there, so that's going to be for one frame. I'll put it on persistent for the video just so you can see what's happening. Then here I get the forward vector, which should be 1 in the forward direction, or rather some sort of vector in the forward direction, and I'm going to multiply it by the teleport range. Right now it's 1,000. You could cut that down, it's in centimeters, and if you've built the world scale that'll make sense. So I'm adding that to the world location, so it's actually pushing from where the hand itself is forward, and then that's the end of that line trace. Right now it's using the visibility trace channel. Those can be modified in the collision presets. Perhaps not that collision preset, but it's in there somewhere. Go find it. So line trace by channel, draw the line. If we hit something, then we will move the player to the new location. Down here's a little bit of math. Since the players can be offset from the center of the scene, like your room is going to be 0, 0, 0, and your room is going to move, not you specifically. That way you stay inside of your chaperone boundaries and everything keeps working. So I get your head location, I get the room location in the world. So your room could start out at 0, 0, 0. It could also start out anywhere on the Cartesian coordinate system. So I've got your head, subtract the room from that. I'm going to break this vector and cancel out the z because I don't care how tall you are. Everybody could be at a different height, and that's not going to influence teleporting. The surface height at which you're pointing is the new height to set the floor. So I'm just going to create this vector which got your new x and y position of your head, or your old one technically, no value for z, and then subtract that from the result of this hit location. So that becomes your new location. If you want to figure out how that really works, break it and try to make it work on your own, and you'll learn all sorts of interesting things, or don't, and just trust me with that. So here's a little demo with teleporting. So here's my teleporting hand. I can click and it teleports me, and when I click on these stairs, it's teleporting me up based on the height. And you can see there's my hand over there, and then that block there, I just set that in the center of the chaperone system, so that's useful for seeing where the floor is. Now another cool thing I've got here is that I turned the lines on, so these line traces are sticking around and you can see exactly where I've moved previously. There's no point to that really other than it looking cool in this debug thing. And it also looks like there's text on my face. We're going to talk about text on my face and collisions with my head, which I can use to knock these objects around. So right now I've got a camera on the player. I've labeled it head because it's always going to be on my head. It's going to follow the rotation of my head, and it's going to be useful for anything I need to do with my head. First off, I've put text on my face. This could be some sort of cool HUD, like Iron Man. I assume that's what his HUD would say. There is some rendering features down here. I've turned it on so only the owner can see this. That means if you're in multiplayer, only you know that you're Iron Man. There's also a head collision, which is a sphere. Let's check it out there in the viewport. I've scaled it to roughly the size of an enormous pumpkin. It's select to block all dynamic. Generally, that's going to just block or overlap all dynamic and generate overlap events, but I want it to block them. To add a collision object, it's a sphere collision, so you just type in collision and you get a couple different collision types. Pick which one works best for you. There's that room center guy. It's just dropped in here just by typing box and dropping it in. And that is about it for this pawn setup. I'm going to jump into this now. Here's these objects. They've got simulate physics on. You can see that by this arrow. They didn't start that way. If they don't have simulate physics on, then they won't move around and it will be dreadfully boring. In this level we have a couple lighting things. There's a sphere capture that captures things. Look it up in the user's manual. It makes your reflections look fantastic. It's cheaper than screen space reflections, and it's generally a good thing to have a lot of those. But again, read the user's manual so you know how to use them. Here is the sky sphere capture light thing. Who knows what it's called really, but this upside down mushroom of magic produces these great ambient lighting effects inside these shadows. Without it, those would be very dark shadows and the scene would look very unrealistic. Graphics do make everything better. Here's the sun. I've got shadows on. You could turn shadows off. They cost a lot to run. Control-Shift, opens up the visualizer. So let's look at this. It's taking 6 milliseconds to run the scene in the editor. Let's actually hit play and see how long it's running here. It's taking 9.3 milliseconds to run it in there. And let's see what is costing that much. Here's lighting, 2.24. So right now that's pretty cheap. Shadowed lights, which happen to be the only lights in the scene, are running in at 2.24 milliseconds. Just for fun, I'm going to turn off shadows. I'm going to hit play. I'm going to do the profiling key again. And now let's check out the lighting. It's now doing 0.51 milliseconds, so we've just knocked off 2 milliseconds. That can be a really, really huge amount of milliseconds, considering you only have 11. Now we're running at 8 milliseconds. You can check out all these other cool options and figure out what's happening. I've got instant stereo running, so there's 2 views. I have Slate UI, and I think that might be the editor itself, so that overhead might not be available if you run the game without running it in the editor. There's base pass. There's our views. Now it's only running 1 because we're in instant stereo, I believe. So that's the profiler. Again, that's Control-Shift, So what else we've got in our scene? You've got those lights. I've got some cool text. You can read that on your own later. I've got this box, which is a post-process volume. It is unbounded. It is now. It wasn't. So you're going to have to check that, because inside the box, things will behave differently than outside the box. So what I've done in here is I've turned off screen space reflections. I've turned off motion blur. I've turned off ambient occlusion. I've turned off lens flares. I haven't turned off auto exposure. I think that's off somewhere else. In general, I've cleaned up the scene, so all these extra effects are gone. Now, if you need those effects, except for motion blur, that would always be terrible as far as I know, you can turn them back on just by clicking that button and it resets it. Right here, we're going to look at the project settings. Now, I've already set these up for you, so you don't have to worry about it. Except for rendering, there's a couple settings here that I've turned off. These were on to start with. Auto exposure was on, motion blur was on, lens flares were probably off, but I turned them off so you don't have to worry about them. There's also some physics setting that I set. This was at 0.3 and I changed it to 0.11, which would run more at 90 frames a second. Another quick tip for beginners is that in your project settings, maps and modes, you want to set that to your default level. Otherwise, when you build your game, you will not start in your actual game level. It will be very disappointing, especially after a long build time. There's the Vive Camera Manager and Vive Controller. I think I talked about those. Just create them. I didn't change anything on the Vive Camera Manager. In the Vive Controller, it's using that's interesting, I seem to have closed an important setting. There we go, class defaults. So the Vive Camera Manager is being used by the Vive Controller, which is being set by the game mode, to go in pair with the Vive Pawn. Now if you had a different controller, you could actually use WASD to make yourself sick. That's why we're not using that. Here's the Chaperone particle system. It's a fantastic particle system. I made this myself, just for you. It's got a particle, which is a billboard texture, but when these are small enough and far enough away from the player, and in this case they almost always will be, they're just fine. And I think that about wraps it up. So grab this scene, have fun with it, play with it, and make some cool games.